Good morning. Today we are going to discuss the preparation of alcohols. There are different methods for the preparation of alcohols. The first method is from haloalkanes. We have already discussed this method in the chapter haloalkanes and haloarenes. I have written an example here. Haloalkane, bromomethane plus aqueous KOH or aqueous NaOH. Substitution of Br minus by OH minus takes place and we get alcohol CH3OH as the product plus KBr is obtained as the byproduct. Now the second method is from alkenes. This is called acid-catalyzed hydration of alkene to form alcohol. That means the addition of water to alkene. In presence of an acid catalyst, we get alcohol. I have written two examples here. The first example is addition of water to a symmetrical alkene. Symmetrical alkene means alkene which carries same number of carbon atom on either side of the double bond. So here we have one each on either side of the double bond. So this is a symmetrical alkene. Addition of water. In presence of acid catalyst H plus, we get alcohol as the product. From H2O, H plus will add to any one of the carbon and OH minus to the other carbon. We get alcohol as the product. Now the second example is with an unsymmetrical alkene. Unsymmetrical alkene means alkene with different number of carbon atom on either side of the double bond. In this example, we have only one carbon on this side. This side we have two carbon atoms. So this is an unsymmetrical alkene. Plus H2O in presence of acid catalyst. Here, addition of H2O to alkene takes place according to Markovnikov's rule. And we know, according to Markovnikov's rule, the negative part of the addendum will add to carbon of the double bond carrying less number of hydrogen. Now in H2O, OH minus is the negative part. It adds to carbon with less number of hydrogen. And H plus will add to the other carbon atom. So the product we get is CH3, CHOH, CH3. And you can see this is a secondary alcohol. This is a secondary alcohol because OH group attached carbon is attached to two other carbon atoms. So this is the second method for the preparation of alcohol. Acid-catalyzed hydration of alkene to form alcohol. Now, here comes the first mechanism from this chapter. And the mechanism is mechanism of acid-catalyzed hydration of alkene to form alcohol. Okay. Mechanism of acid-catalyzed hydration of alkene to form alcohol. It takes place in three steps. The first step is protonation of alkene to form carbocation by electrophilic attack of H3O plus. H2O plus H plus, we get H3O plus. Now H3O plus acts as an electrophile and it attacks the alkene to form a carbocation. Look at this step, CH2 double bond CH2 plus H3O plus. Now in this step, the single bond here gets shifted to oxygen. As a result, the positive charge on oxygen gets neutralized and it will be removed as H2O. Now here H plus will be shifted to this carbon atom because this carries a partial negative charge. So we get here CH3, CH2 with a positive charge on this carbon and that is our carbocation. Now step 2. Is the nucleophilic attack of water on carbocation to yield protonated alcohol. So in the next step, it is the nucleophilic attack of H2O on carbocation. This is our carbocation formed in the first step plus H2O. You get a protonated alcohol. Protonated alcohol, you can see the lone pair is taken by carbon and a bond is formed between carbon and oxygen. This is the bond formed between carbon and oxygen. CH3, CH2, OH2 and a positive charge on oxygen, which we call this as protonated alcohol. And you can see the first step as well as the second step are reversible. Now comes step 3, deprotonation to form alcohol. CH3, CH2, OH2 plus. This is our protonated alcohol. In presence of H2O, the bond between O and H gets shifted to oxygen. So this H will be removed as H plus ion, which combines with H2O to form H3O plus. And we get CH3, CH2OH. That is our alcohol final product. So the mechanism for the acid catalyzed hydration of alkene takes place in 3 steps. The first step is the electrophilic attack of H3O plus on alkene to form a carbocation. Second step is the nucleophilic attack of water on carbocation to form a protonated alcohol. And third step is the deprotonation to form alcohol. Next method for the preparation of alcohol is by hydroboration oxidation reaction. In 11th, we have learned about diborane. The formula of diborane is B2H6. And diborane is the dimer of borane. The formula of borane is BH3. So, we are going to prepare alcohol from borane, and the method is called hydroboration oxidation reaction. Again, you can see on the board, we start with alkene, propene plus BH3. Now I've taken one hydrogen out and it is written as HBH2. You get an addition product. And you can see in the first step, in HBH2, it is the boron that forms a bond with double bonded carbon which carries more number of hydrogen atom. So you can see here BH2 adds to double bonded carbon with more number of hydrogen, and the hydrogen atom, one of the hydrogen atom from BH3 will be added to the other double bonded carbon. And you can see here CH3, CH, the single bond CH2, BH2. Now in the next step, this is one addition product. Now in the next step, another molecule of alkene, propene, is added to this. Now here also, when you write the reaction, I'll show you how the addition takes place. CH3, CH, CH2, BH2, CH2, CH2, BH2. Plus, we are going to add CH3, CH double bond CH2. Now what happens is, from BH2, one hydrogen will be added to the carbon of the double bond with less number of hydrogen, and BH will be added to the double bonded carbon with more number of hydrogen. So I am going to remove one hydrogen from this BH2 and I am going to add this alkene, and you get CH2 single bond. From that hydrogen gets added to CH, so it becomes again CH2, and we have a CH3 here. Now when you write this condensed formula, it is CH3, CH2, CH2 twice BH. Now which again adds on one more alkene to form a trialkyl borane. This is CH3, CH2, CH2 thrice B. Now this trialkyl borane will undergo oxidation with hydrogen peroxide and NaOH to form alcohol as the final product. Plus we get the byproduct BOH thrice, or we can also write it as H3BO3, which is called boric acid. So this is hydroboration oxidation reaction. So in hydroboration oxidation reaction, the boron atom adds to double bonded carbon carrying more number of hydrogen, and the hydrogen atom will add to the other carbon atom. and the trialkyl borane will undergo oxidation with hydrogen peroxide and OH minus to give alcohol and boric acid as the final product. Now if you look at this reaction, look at the alkene taken, it is propene, and the alcohol formed is propanol. If you look at this reaction, look at the alkene and the product alcohol formed. If you look at this, it seems as if addition of water has taken place to alkene, to an unsymmetrical alkene by anti-Markovnikov's rule. So look at the product. Okay, so this is hydroboration oxidation reaction. Next is the preparation of alcohols from carbonyl compounds. Carbonyl compounds, general formula is C double bond O. So we have aldehydes, ketones, carboxylic acids and esters which contain carbonyl group. So we are going to prepare alcohols from carbonyl compounds. First we are going to prepare alcohols from aldehydes and ketones. Reduction of aldehydes and ketones give alcohol. And aldehydes on reduction give primary alcohol and ketones on reduction give secondary alcohol. And the common reducing agents used are hydrogen in presence of platinum, palladium, nickel catalyst, lithium aluminum hydride and sodium borohydride. So this is very important. Aldehydes on reduction give primary alcohol, ketones on reduction give secondary alcohol. I've written examples here. Aldehydes CH3CHO. CH3CHO plus H2 hydrogen in presence of platinum catalyst. And you can see since oxygen is more electronegative, the bond will shift to oxygen. It gets a partial negative charge. Carbon gets a partial positive charge. Hydrogen, one hydrogen atom will add to oxygen and the other will add to carbon. So you get the product as CH3CH2OH, which is a primary alcohol. So aldehydes on reduction give primary alcohol. And the name of this aldehyde CH3CHO, since there are two carbon atoms, the IUPAC name is ethanol. And the common name which is also accepted by IUPAC of ethanol is acetaldehyde. A very important aldehyde. So the formula of acetaldehyde is CH3CHO. Now next example is with a ketone. I have written the formula of ketone as CH3COCH3. CH3COCH3. And since there are three carbon atoms, we can write the name of this ketone as propanone. Or the common name accepted by IUPAC is acetone. So acetone or propanone formula is CH3COCH3, and which is the simplest ketone. Now this on treatment with hydrogen in presence of platinum catalyst, we get a secondary alcohol as the product. We get CH3, again here C double bond O, double bond breaks and hydrogen adds to carbon and oxygen and we get the product as CH3CHOH CH3. So from aldehydes and ketones to prepare primary and secondary alcohol, we use reducing agents. Reduction of aldehydes give primary alcohol, whereas reduction of ketones give secondary alcohol. Now this method cannot be used for the preparation of tertiary alcohols. Now next comes the reduction of carboxylic acid and ester. Reduction of carboxylic acid and ester will give primary alcohol. I've written two examples here. In the first example, carboxylic acid with reducing agent lithium aluminum hydride followed by hydrolysis, you get primary alcohol as the product. I've written a general equation. Now, since lithium aluminum hydride is an expensive reagent, we use or we convert acid first to ester followed by reduction of ester in presence of catalyst gives alcohol. So RCOH, and we know how to prepare ester, acid plus alcohol in presence of sulfuric acid, you get an ester. So RCOH plus R-OH in presence of acid H plus gives RCOOR- ester, which on reduction with hydrogen in presence of platinum, palladium or nickel catalyst, we get two alcohols, RCH2OH plus R-OH. So this is from carbonyl compound, aldehydes, ketones, carboxylic acid and ester for the preparation of alcohols.